this question. Figure shows a uniform rod of length 30 centimeter. Okay, 30 centimeter length. This is 30 centimeter. You can see 10 centimeter, 20 centimeter is given. Okay, mass 3 kg. The strings shown in figure are pulled by constant force 20 Newton and 32 Newton as given in the diagram. Find the force exerted by 20 centimeter part of the rod on the 10 centimeter part. All surfaces are smooth and string and pulley are light. Okay, so first thing what we are going to do here is, since this rod is given uniform, we will write the mass of these two parts. So the mass, suppose we write mass of this part is MA and mass of this part is MB. So since whole is 3 kg, so 1 kg will come in 10 centimeter and 2 kg mass will come in 20 centimeter, because they are more part is there in the 20 centimeter. The part in the MB or second one is double of the part in A. So MB we can write as 2 kg and MA we can write as 1 kg. So they are simply what? The mass will be proportional to length. That's why it is there. Okay. So now what are the equation which we can write? Suppose the reaction force between these two is R. The reaction force is R. This is the force which we need to find. The force between the two objects, that is R. So this force we needed to write. Okay. So we will write the equations. So for A or for MA, so what are the different forces? You can see different forces. One is on MA, the string will pull like this. So force will be like this in rightward direction. So that is R acting. And then there is a 20 Newton acting through this tension. That is 20 Newton. 20 Newton. This 20 Newton is what? 20 Newton is acting through the left string. Okay. And then we have weight. And then we have normal from the ground. Suppose NA we write. So weight and normal. Okay. So that is weight, MAG and normal. So we can see that in vertical direction the forces are balanced, so no need to write vertical forces. So what we can write is R. Since the whole system will move in rightward direction. Why it in rightward direction? Because rightward force is more. The 32 Newton is more and 20 Newton is less. So this side force, the 32 Newton is more than the 20 Newton force. So the whole system is going to move in rightward direction. So we can write for this object also, for A, R minus 20 Newton equal to MA into A. Whatever acceleration, suppose the acceleration of whole system is A. So we can write like this. Okay. Similarly, and we have not written any friction because the surfaces are smooth. Next, we can write for MB. For MB, if we write free body diagram, this is the free body diagram. The free body diagram for MB is the 32 Newton force rightward, then reaction force will be acting backward. The reaction force, it is acting like this on MB. So R, then we have the weight, MBG, then we have normal force, the normal here from the ground. The normal force NB from the ground. So these are the forces acting. So normal will act from here, and here normal is acting like this. So this is NB. Okay, and there is a weight also. So all these forces we have written. Along vertical, no need to write any equation because the system is balanced. Along horizontal, we will write 32 Newton minus R equal to MB A. So these two equations we can write for 32 Newton. Okay. Now next what we will do is, this is equation 1 and this is equation 2. So we will just add these two and we will see what is happening. If we add, we can get the acceleration, or finally we need to find the R. Okay, so if we add 1 and 2, R will get cancelled. So we will have 32 Newton minus 20 Newton equal to MA plus MB A. So A is, how much is this? 8 Newton divided by MA plus MB. So that is 8, so not 8, sorry, 12 Newton. So 12 Newton, so 12 by, this is 2 kg, 1 kg plus 2 kg. So 3. So we are getting 4 meter per second square. This is the acceleration. Now for R, we can use any of the equations. Suppose we use this equation. So we have 32 Newton minus R equal to MBA. So R will be how much? R will be 32 Newton minus MBA. So 32 Newton minus, how much is MB? MB is mass of this block. That is how much? That is 2 kg. 2 kg into acceleration is 4. So how much we are getting? 32 minus 8. So we are getting 32 minus 8. So 24 we are getting. 24 Newton. So this much force we are getting. So this much force will act between the two objects. Suppose we have a rod and we apply a force F1 in this direction and F2 in this direction. Okay. And we have to find, this is uniform rod. So this rod is uniform. And mass of the rod is, mass is not given. Suppose mass is not given. And you have to find displacement, we have to find the reaction, the tension in the rod at a distance x. This is x. Whatever tension will develop here. So some tension will develop or reaction force will develop. So that we need to find. So we are provided a uniform rod. On two sides we are having force acting F1 and F2. These two forces are acting in opposite direction. It is also given F1 is greater than F2. So the overall, the rod will move in the rightward direction and the rod is uniform. You have to find the tension in the rod at a distance x from the left end. So at this point we have to find the tension. Okay. So how to solve this? Okay. So for this, what we are going to do is we will imagine two different objects. One is, suppose this is A and this is B. And the forces, reaction forces will develop like this. Suppose we write as T, reaction forces as T, and this side is F2, this side is F1. Okay. So we can solve in various ways. First, we will find the net acceleration considering the whole system together. So if you consider the whole system together for whole rod, if you write equation for whole rod, if you write the equation, we can write acceleration is equal to F1 minus F2 by whatever mass. Suppose M is mass. M is mass. It is not given, but we can assume from our side. Okay. So this is the acceleration of whole rod. Now we will write for, since we need to find the tension internal force, by writing the whole system we cannot find internal force. So we need to write separately for the two systems. So suppose we write for A, for part A of the rod, for part A. So for part A, if we write, we need to write the tensions here, forces and acceleration, since it will remain same for whole rod. We need the mass of A also. So for mass, first we will write mass of A. Mass of A, suppose MA. How much it will be? Mass of MA will be in the proportion of its length. So it will be x, the x length, the x is the length of A part, into mass per unit length. So mass per unit length. Suppose whole length of the rod is given, that is L. That will be given in the question. M by L. This will be the mass of part A. Total mass divided by length, that is mass per unit length into x. If you multiply it with this length x, you are going to get mass of part A. Now we will write equation for A. Equation for A. So for A, what will be equation? What are the equations for A? See, since this is pulled, actually on A the force will be like this. This is the force on A. The force, since it is pulled like this, the force on A will be what? Rightward, and force on B will be leftward. This force is on B and this is on A. So we can write T, this is on A from B. Okay, and then we write F2 here. These are the two forces, and as a result of these two forces, the whole system, the A is moving. The A is moving like what? T minus F2, that is net force, that will be equal to MA into acceleration. So T minus F2, and how much is MA? MA is x m by L, and A is how much? F1 minus F2 by M. We can do like this. So M cancelled. So we are having T equal to F2. F2 will go on the other side, and then we have plus x by L F1 minus F2. So this is the tension force as a function of x. Means at a distance x, this is the tension force. So if you increase the x, you can see, if you try to see what is its meaning at x equal to 0, how much is the force? If you put x equal to 0, this whole thing will be 0. So tension will be equal to F2. So here the tension is same as this force F2 at the left end. And as you move forward, as you move from left end to right end, the x is increasing. So that tension will also increase. And at x equal to L, if you put x equal to L, so what you will get? This will get cancelled, and F1 minus F2. So F2 will get cancelled, so you will have F1. So T becomes F1. So at right end, you can see the tension is F1, and at left end, the tension is F2. And the tension will vary linearly with x. Are you getting? It is going to change linearly. Means from here it is F1, F2, and as you move rightward, the tension will slowly increase, and finally it will reach to maximum F1. Okay, you can verify this result. Suppose let some value, let F2 is 0, means from the left side we are not pulling the object, and F1 is suppose 20 Newton. Okay, so in this case, what will be the tension? So you can find tension, and length you can take. Length is suppose 2 meter. Okay, so you can write F2 is 0, x by 2, and F1 minus F2, that is 20 minus 0. So how much we are getting? We are getting 10x. So the tension which we are getting is 10x. So what does it mean? You can see at x equal to 0, the tension is 0. At left end, tension is 0. As you move rightward, tension increases linearly, increases. When you reach x equal to 1 meter, you can write x equal to 0 means T equal to 0. X equal to 0.5 means T equal to 5 Newton. X equal to 1 meter means midpoint. Tension is 10 Newton. X equal to 1.5 meter. Tension is 15 Newton. And if you put x equal to 2 meter, the tension is going to be 20 Newton. Okay, so as you reach to the right end, the tension now becomes equal to the applied force F1. Okay, so in this way you can understand this concept. So that was the thing also happening in the last discussion. In this one we have the similar kind of thing.